Well, all right, everyone. Welcome to the quick and easy talk today about making Cosmos data trustless. I'm Fabian. I'm the founder of KYVE Network. It's going to be, it's quite an easy little bit talking about today's data roadblocks, a little introduction about what we do at KYVE, and then kind of like how certain ways of like how you can access the data that we are like storing with KYVE and kind of like all of the stuff around it. So what is like the current problem in the blockchain data space? So first of all, actually kind of like node syncing and like accessing all the big amounts of data is just tedious and time consuming. So I mean, if you want to sync like a full node on ETH, it just takes weeks or even longer, right? Archival nodes are just not incentivized, except you're like running them as an RPC service. So you might want to like create a service out of this. You have a high risk of running into invalid and out-of-date data. Actually, there are some networks out there where it's just even impossible to even recreate the full archive because they changed the technology in between or like the hardware that was used, since you would need to find a specific hardware at a specific point in time just to sync that certain time frame, and just getting more and more tricky accessing that data. And then, of course, also if you actually read from a blockchain, you're not actually reading from the blockchain, right? You're reading from an RPC node that is connected to the blockchain, but actually they are kind of faulty sometimes. I'm not sure if the result you get is actually correct. You just trust it because, well, the writing part, that is easy. You kind of trust this, but then when you read, you're just like, is it correct? You might want to ping a second RPC service just to figure that out. So it's just like a big mess. And then, of course, you have all the different like data requirements, and you have different use cases. Something we see, we have like a dual analytics specializing in like SQL data access only. You have a graph specializing in GraphQL data access only. But I mean, if you're like a developer, you of course want to like stay in the tech stack you're familiar with, or especially stay in the tech stack that kind of like brings the most value. And maybe like GraphQL isn't the solution you're looking for, so you'll be kind of like maybe looking for like a streaming optimized database or things like that. So what is KYVE and how does KYVE work? KYVE is a fully decentralized data lake. We're living on the Cosmos SDK. We have quite a tech journey behind us. We started out being fully Arweave based, and we were storing the data on Arweave. Our smart contract logic for the token was sitting on Arweave. And then, we realized the Arweave contracts weren't as production ready back then as we needed them. So we transitioned over to Solidity contracts, then realized that, actually, when we need to share app space and things like that, it might actually get quite costly for us because we just can't compete with like a Uniswap where you make 10K profit on a trade, and then it's fine if you spend $100 in gas fee. That just doesn't work for like application specific or like use case specific applications, so to say. And then in, I think it was February last year, we then transitioned our logic off to be a Cosmos SDK app chain, and of course still storing the data on permanent storage like Arweave or Filecoin or just other kind of like storage backends. We are very generalizable. And so basically, if you're a developer, you can choose, which data do you want to store, where do you want to store it, and kind of like how do you want to interact with it. And everything we do happens on-chain, so it's fully trustless and it's immutable. And of course, it's easy to access with kind of like certain data tools we build around the data lake we are building. And this will kind of like be what I will be highlighting on today. We have many active integrations right now. We are very blockchain space agnostic, not only blockchain, but actually data agnostic. So we started out as a grant actually from the Parity and Arweave team to archive the Polkadot data onto Arweave. And then we realized that, actually, there's kind of a cool use case and something that is needed not only in the Polkadot ecosystem, but actually all around the Web3 ecosystem. And so we rather quickly extended into EVM compatibility and other chains. By now we support, I would say, basically almost every big L1 out there, and also some, not Web3 data sources, but actually Web2 data sources like weather data, IoT data. But I will kind of like deep dive into these use cases a little bit later. So what are the KYVE data pools? The KYVE data pools are kind of like the core of how we build up our decentralized data lake. They sit completely on chain, and they only store like the meta information. So what is the name of the data you're storing? What is the code that is executing? Which nodes are active in this? And basically they can be created by anyone in the governance. We are changing it right now, so actually you can just create a data pool without going to go through the governance, kind of like our end of the year goal. And so basically, how do they work? So if I'm a developer and I want to store, let's say, Polkadot, I would create, it's called a runtime, where I define one function where I define how do I get my data. So for example, I request block number 5 would be, I request a Polkadot RPC endpoint, get block number 5, store it onto permanent storage, submit it on the pool, and be like, hey, everyone else, here's my uploaded data, please validate it. And then the other nodes, they go ahead, they download the data, and they execute the validation function. And the validation function is completely generic and can span from, I want to check if my data is an exact copy, to, my data is almost equal. Like for example, for pricing information, it's something where you might want to use this, like, does the price from Coinbase is almost equal to the one from Binance, and if yes, I'm going to vote valid or invalid on it. And then, once all the nodes have submitted, they're voting on the data. The blockchain or the pool is then computing if the uploaded piece of data is valid or invalid. And if it's invalid, we don't keep a track of it. And if it's and if it is valid, then we keep track of it, and then developers can query for that specific piece of data from our blockchain, knowing it is 100% correct and has not been tampered with or modified with. Funding a data pool is like the most important part in the core of KYVE's tokenomics. The way it works is these data pools, they require funding, and every time a node paid out a piece of data, it gets rewarded in KYVE tokens from this pool funding. If a pool ever runs out of funding, it just pauses and doesn't upload any new data. So if you build your application on top of KYVE, you're kind of like incentivized to keep the pool funded, so the stream of data you are working with keeps being stored. In case a pool runs out and it pauses, it just pauses at the block height or whatever key you specify, so we'll never have any data gaps. Up to 50 projects at the same time can fund a pool. We're also kind of reworking the funding system right now, maybe also a little bit more about this later. And then who funds a pool? It's usually projects that are building on top of the data KYVE is producing. For example, if you're building your own indexer, right, you always want access to the latest KYVE data, so you would be keeping the pool funded to make sure there's always new data is being stored and you can use it in your system. And then what are different ways how you can access the KYVE data? Well, the most easiest one is to use our REST endpoint. So you can just query on-chain using our like an LCD RPC client for kind of like all the bundles you have going on there. It's a very tricky way because our chain only stores the ID on the storage provider the data is stored. So let's say if you store your data on, for example, Arweave, we just say, this Arweave ID is valid, and then you would kind of like have to interface it with yourself and download it, and then you can insert it into your database. Data is also compressed, so you can kind of like choose what kind of compression mechanism you want to use. And I think the storage provider is the most crucial part when you're building your own integration, thinking about what are kind of like my storage requirements. Do I need 200 years permanent storage? Well, then Arweave might be a good idea. Do I only need like 5-year short-term storage? Maybe Filecoin, maybe IPFS might kind of like fit your use case. So we kind of like build it in a way that developers have it very easy to interact with it. The kind of like more robust way and easiest way to interact with KYVE data is to use our ELT pipeline. For everyone who's unfamiliar with ELT, it's a concept out of data science. It's while you first extract the data from the source, in this case it's KYVE, you load it into your chosen destination. It could be your Snowflake cluster, it could be your Postgres database, and then the client does the transformation on their side. It's ELT versus ETL. Some other use cases you might prefer ETL over ELT. Let's say, you have specific customer data and you know exactly which format you want on your end. You can do the transformation on the fly. It's kind of like saving you a little bit of development work. With blockchain data, we found actually that most of our clients want it as raw as possible because it's just such diverse data, right? Like let's say Ethereum, for example, you might find value in NFT data extraction, like which users have bought which NFT. Some others might be interested in DeFi. Some others might be interested in whatever other application is going on. So kind of like working with the raw data, and then you can decide what you want to do on your own is the approach we chose there. And so our data pipeline, it's a no-code solution. You can just spin it up. It's fully trustless. You can use it in your own system. You also have a hosted version. We're using a framework called Airbyte for this. Maybe some people of you have heard of it. It's a more generalized ELT framework. They have a cloud version. You can use this. KYVE is fully integrated there. Don't need to spin up anything. If you decide you want to keep it fully trustless, you can just execute it on your own machine. It's just a Docker container. And it's very easy. Basically, it's a nice interface. I hope if I have enough time at the end, I can give you guys a quick demo of what it looks like. But basically, you just select, oh, I want to get the data from the Polkadot KYVE pool, and here's my destination, which you can see Airbright supports so many destinations. I think everyone really finds what fits their use case best, and just one click and automatically syncs all the raw data in it. You can define custom normalization. If you say, oh, already my transactions should already live in their own table on SQL, for example, you can just import everything in and then just do your data analytics on your own, build your own queries around it. We have a couple of cool use cases spanning from the most basic data analysis to actually, for example, maintaining old queries that got removed that were interesting for old dashboards that got built. Osmosis, for example, a good option there where they removed old state queries because they are too intensive to query them from the chain directly. And so the team from Imperator, for example, is looking into a solution how they can recreate that and maintain these old queries by then querying trusted off-chain data from whatever data framework they choose to deliver that. Another use case for KYVE that we as a team have built out is called Ksync. What it does is it allows validators or node operators to sync their node without actually having to be connected to the P2P network. So there's a couple of advantages. The first thing is that actually it takes a lot of time for your node. We always call it the old kids don't want to play with the new kids coming in. Actually, it takes up to 20, 25 minutes sometimes until your node is connected. It needs to sync data. It can get kicked out. So it's kind of a faster way using the KYVE data and just syncing the node directly. We do support DB sync, which allows you to sync your database from your node directly, or we can mimic a P2P node. So it means that the nodes think it's actually connected to the blockchain network, but in reality it isn't, and it's just talking to a mocked endpoint and getting the data actually from KYVE in the background. Has a couple of cool advantages. It eliminates the need for archival nodes because you can just sync to whatever point in time you want, and you can just prune to whatever time you want. So let's say you only want to investigate a certain area of blocks, you can just do it using this. It's very easy to install. It's actually just a wrapper around your daemon. It just executes automatically. It knows exactly which data storage to use, which provider to use. We're also working on a state sync application right now. So on block sync, you have to consume every block one by one, apply to get the state for every block height. So it also takes some time. And then the cooler thing actually to store is to work with state sync, where you can store the state at every given block height. So it's much more easier to use because you just tap into, oh, I want to see what the blockchain looked like on, 1st of April 2022. So you download a block from that date, and you just see exactly what it looked like. So it's much easier to do holistic analysis. Another nice little tool we have, it's called Supervisor. A couple of feedback we got when the people were using KYVE, especially on mainnet, was that it requires you to have a node, a real node, that's connected to the network running at the same time where you run your KYVE node. So let's say on mainnet we are running the Cosmos Hub archival right now. So you need to run a Cosmos Hub node and a KYVE node. And of course, because they're talking to each other, the Cosmos Hub node needs to sync and basically creates a full archive. And this is, of course, what we wanted to get rid of, that people need to run their archival nodes. So created this script called Supervisor. And what it does, it's communicating back and forth with your KYVE node. It's actually pruning the data that you are syncing only up to a certain height and only from a certain height. So let's say when the KYVE pool right now is archiving the block height between 1,000 and 2,000, Supervisor makes sure that your node that you're talking to only has the data from, let's say, 800 to 2,500. So you're not running into an unnecessary cost situation. We're actually running a way more expensive node than you actually do. And actually, in some cases, it's the only way how you can even sync all the data, because the pure archival node would get so big. It just be no economical sense to run it on your own. Another cool way on how we are sending data from A to B, it's our x/Oracle module. It's in development right now. We're using IBC there, and then we can use other IBC bridges like Accela, for example, to send the data across the whole blockchain ecosystem. It's already integrated with all IBC chains because we're just utilizing the ICS 20 stack there. You can use Accela and Squid. You just pay in any token if you want to execute the query, and it's just super handy if you have an Oracle use case, for example, on your chain and your Cosm wasm contract. and you want to access data that has been stored there, you just basically would query it through an Oracle module, and it would ensure it's fully trustless and stays kind of like in the fully on-chain ecosystem, so to say. What does the next kind of like couple of months look like for KYVE? We launched our mainnet in March. Since then, we launched one data pool, which is the Cosmos Hub data pool there. So we are almost done with syncing, and we have a full archive of that created. So this is the protocol launch. Token listing is coming up next, as well as the Oracle launch, which is the IBC transfer thing. And then basically what we really focus on for the rest of the year is just data pools, data pools, data pools. We have very cool ecosystems in the pipeline, spanning from all the Cosmos platforms to, of course, the EVM chains again, storing their data. And then something we are very, very excited about is we have our first external project building on top of KYVE. It's called Logstore. And then, I don't know if you guys are familiar with like the Elasticsearch stack. They have also a thing there called Logstash, which basically you deploy to machines. The machines send all their logs in a decentralized way, and basically they've done it to then collect the data using KYVE and Arweave, and then make it from there available for developers for kind of like the long-term analysis of things. Because this is something you have to keep in mind when working with KYVE, because the data gets voted on and uploaded. We have like just a normal delay of like around 30 seconds. So we get a lot of questions about like real-time usage, but honestly, real-time data validation is kind of tricky. If you want to send the data around the whole world, you already have latency. You need the nodes to vote on it. That adds latency, so real-time is almost impossible. And they have a cool system. They use the streamer network. It's a decentralized pub sub network. So they publish the data immediately, and then everyone who's subscribed to it just gets it into their database. And then they're waiting for KYVE 30 to 45 seconds later to actually confirm the data is valid. And then they overwrite the data in the database that they then get from KYVE to ensure that they're working in the fully trustless space, so to say. And yeah, I think it was a very, there you go. It was a very high-level, intensive overview about that. Happy to answer any questions. We have like 5 minutes left if there are any. If not, thank you so much.
I'm a bit curious about the
Yes.
choice of database provider.
Yeah.
How is the choice being made? Is it up to the user? Or?
Yes, exactly. So basically, you can decide on both ways. So the first decision you can do is when you store the data using KYVE on-chain. So there, of course, we recommend like a decentralized storage provider. Arweave is usually a good choice and things like that, because you can just dump all the data on it. It's cheap and it's stored. But let's say you want to store your data in S3. There's nothing wrong with this. We have an easy storage interface. You just write in like, how you usually connect to S3, for example, and then it's getting stored there. And then when you jump back to the ELT pipe, here, to the was this what you were referring to on the ELT pipeline, or was it the on-chain data storage?
No, it's the database provider. I mean, for example, in some cases you might want to restrict where the database is located.
I see. No, so this is something you can fully decide on your own. So you would kind of like stay in whatever architecture you usually use, let's say using Amazon RDS, like Postgres, for example, to store your data. You just set up your normal local database cluster, how you always do. You just spin up the ELT pipeline, point it to your database endpoint, click run, and it just syncs it automatically. This is all handled by this framework we're using there. So you can choose whatever database you prefer and whatever you're willing to work with, so to say. Exactly. And it's the cool thing also, because we're storing the data with Arweave, it's free to access. Because Arweave is free on the data access side of things. So the moment it's stored, just click one button, it's getting straight into your database, and that's it. We also have a cool tech demo about this online. Also, if you want to check out the docs, it's like a little section about like a Postgres example and a Snowflake example. So feel free to also play around with that. It should be quite an easy start. Exactly. Yes?
When you say the data is validated, how does that happen exactly?
Yeah, so this is also a cool process. So basically, we have 50 nodes active in one data pool. And one of the nodes is randomly selected to be the uploader. So we only upload the data once, and then once the uploader has uploaded the data on chain, the other nodes download it, and then they just execute a validation function. So the validation function is just an interface, and it just needs to return either true, false, or abstain. And then you can write whatever logic you want in between to validate your data. So something we do for blockchain data, because that's quite easy to validate, we just say, well, does my local copy equal the copy that got uploaded? Right? That is like a very easy validation check. But you can make it more and more complex by, for example, checking for ordering, or let's say if you work with pricing data, right? Like, oh, is the slippage not higher than X or Y? And then the nodes would vote on this. And actually it happens quite sometimes that the RPC endpoint you're connected to goes offline, for example, and then the nodes just can always vote with abstain. So if you're unsure, vote abstain, and if the majority votes abstain, the bundle just gets dropped. So it just kind of like is stuck in an infinite loop until like a human steps in and fixes it, for example, in case the data is not deterministic, the validation function is broken, or the endpoint is broken, or things like that.
Okay.
Exactly.
And so how do you provide such function in the transaction? You provide the function?
No, so basically we have our own JavaScript library, and you just override the interface that we have there, you build it, and then you just deploy it to the pool. So in the pool you say, it's a shame the Wi-Fi here isn't working very well, because I would love to show you like a little demo in the app, but basically every pool has a fixed runtime, and then all the nodes execute this binary. So you can build a binary however you want, you can add as much customization to you. The people that are building their own stuff on top of KYVE, it's crazily customized because they're using Streamer and all the other things, but they just ship the binary and all the nodes execute it, and that's how it works. Exactly.
Curious, what do you feel are the most relevant competitors for KYVE?
That is a good question. I think for us, we're also still trying to figure that out a little bit. In the beginning, there were a lot of questions like, oh, are you competitor to the Graph? Are you competitor to Dune? But actually, I think we're sitting much deeper in the tech stack, right? Because actually, the Graph is they can be big user of KYVE, so can Dune, right? Because they don't need to worry about building their own like data pipeline infrastructure. They can just tap into some already existing data and just pull into their system and make it available immediately. I would say on that level, we don't have many competitors yet. Of course, you have kind of like the messaging protocols. They go into the direction, but they only work with deterministic data. So here it's kind of cool that you can like choose it on your own where you want to store it. We are highly modular. I think it's the new cool word for that. But basically, yeah, I think even for us, we don't see many competitors yet in that space. Yeah.
You want a hotspot to show?
I'm happy to do that. Actually, that's a good idea. Let me see. Perfect. If I quit this.
And what kind of application do you think would be the biggest users of KYVE?
Yeah, I think it would start out definitely with, you guys as validators, right? Because you just are so much into all like the node systems, right? Work with this, you know all the pain we go through every day, right? Like how fragile some of the networks actually are and things like this, and actually just being able to just sync a node without having to worry about it is pretty powerful. And then this is something also kind of very interesting for us. It's like, well, KYVE grows with every little piece of data we add over the next couple of years. So this is like the most interesting challenge compared to other protocols or products. We just launch and you usually have access to a big ecosystem. Here it actually takes some time, and also, the older the data, the more valuable it is because the harder it is to get. Like Solana, for example, Solana block 0, I don't know if it even exists on some archival nodes. It definitely exists in the BigQuery instance, but I don't know if it even exists on some nodes. So that's kind of like interesting to see. And yeah, as you can see, some other blockchains, honestly, they're not old, maybe like 2 or 3 years, and it's already impossible to like get their early data and create an archival and things like that. So it's getting, very, very interesting time for us to look into that. Let me connect to hotspot and see if I can make it happen. Also be, let's see. Yeah, it looks, I'm connected. No.
Just got the request to share the
Oh, with me? Nice. No, it doesn't look like it's connecting. Let's check with the hotspot. Does it open on my screen? Perfect. guess this side. Nope, my hotspot doesn't want it. Let's try the Wi-Fi one more time. Well, I'm sorry, everyone. Looks like the Wi-Fi and the hotspot's not. Oh no, it's not successful in here. But yeah, feel free to check out KYVE Network. I'm happy to stay around, answer any questions once. Oh, now I get the big exclamation mark on the Wi-Fi once it's working. And yeah, happy to answer any questions if they are. And thank you so much for listening in today.